Alright, so today we're going to be starting Chapter 4. We're going to be talking about trig functions. In Section 4.1, we're going to be talking about degrees and radians. A degree is a unit of angular measure equal to 1/180th of a straight angle. That makes sense because we know that a straight line is 180 degrees, right? A degree is 1/180th of that line. In the DMS, which stands for degree, minute, second system of angular measure, each degree is subdivided into 60 minutes, which we denote with 1 dash, and each minute is subdivided into 60 seconds, which we denote with 2 dashes. So in our first example, we're going to have to be able to convert back and forth between these two types of measurements. Example 1 is going to ask us to convert this degree measure to DMS. So, if I told you that something is 37.425 degrees, I want you to convert that to DMS. Well, what this means is that you're going to have to take, you know that it's going to be 37 degrees, some minutes, and some seconds. We already know that the 37 is whole, so I'm going to take the decimal part of my degrees and change that. I'm going to change 0.425 to minutes. And I know that there are 60 minutes in 1 degree. So when I multiply that out, I get 25.5 minutes. Well, I still have this 0.5 here, and I'm not allowed to have a decimal, so I need to change that to seconds. So now I'm going to do 0.5, and I know that there are 60 seconds in 1 minute. And we know that a half times 60 is 30, so that means that I can write my final answer as 37 degrees, 25 minutes, 30 seconds is how you would write your final answer for a problem like this. Now we're going to do a similar example, except we're just going to go the other way. So this time I want you to convert 42 degrees, 24 minutes, and 36 seconds. 36 seconds into just degrees. So what you're going to do first is you know that 42 degrees is going to be the whole number, and it's going to be point something degrees. So we need to start with the fractional part first. We know that you're going to take 24 minutes and divide it by 60. And you also know that you're going to take 36 seconds and divide it by 3,600. I'm going to add these together to get the decimal part of my answer. So, when I add this together and I multiply out or divide out, I get 4 degrees plus 0.01 degrees equals 0.41. And so now I'm just going to take that 41 and put it as my decimal. My final answer then is going to be 42.41 degrees. So let's talk about radians. Radians are really important, and we're going to be using them a lot. So it's very important that you understand what a radian is and why we use this measure. So a radian is a central angle of a circle that has measure 1 radian if it intercepts an arc with the same length as the radius. What does that mean? Well, if I draw an angle, any angle, and I draw the arc of a circle. So, pretend as if this was a big circle, and I drew an angle with the arc. If this measure is A, some number A, and the arc is also A, then that means that this is 1 radian, which we abbreviate rad. So if the radius, or this length, matches the arc length, that means it's 1 radian long. We can switch back and forth between degrees and radians. It's pretty easy, and we're going to talk about in class how to make sure that you know which mode your calculator is in. It's really important to be in the right mode in your calculator in order to get the right answer. In radians, if I'm transferring radians to degrees, so radian to degrees, I'm going to be multiplying by 180 degrees over pi radians. Oops. If I'm going from degrees to radians, then that means I'm doing the opposite, multiplying by pi radians over 180 degrees. So let's try a couple of examples. In the first examples, I want to know how many radians are there in 90 degrees. So this is going to be letter A. If I gave you 90 degrees, how many radians? Well, since pi radians and 180 degrees both measure one straight angle, I'm going to be taking 90 degrees and multiplying it by pi radians over 180, just like we said in the previous slide. My degrees then would cancel out, and I'd be left with just radians, and you know that that's going to be 90 pi over 180, which is really the same as pi over 2 radians. Pretty easy. Let's try backwards. So in this next example, you're going to be converting pi over 3 radians to degrees. So same thing, you're just going to go opposite. I'm going to take pi over 3 radians and multiply it by 180 degrees over pi radians. My radian units would cancel out, and I would be left with just degrees. And that's going to give me 180 pi divided by 3 pi. Notice the pi's are going to cancel because we don't usually have pi in terms of degrees. And you're going to be left with just 60 degrees. Now the next question is a little bit different. This next question says, a central angle of 1 radian intercepts an arc of length 1 radius, which is 5 inches. Therefore, a central angle of a half radian is how much? So you're finding the length of an arc intercepted by a central angle of a half radian in the circle of radius 5 inches. What does this mean? Okay, well, let's draw our angle with our arc again. And remember, in the previous slide, we said that this length needs to be the same as the arc in order for this to be 1 radian. Well, the question says that it has a radius of 5 inches, so I know that my radius is going to be 5 inches. If this was 1 radian, then I would know my arc length is also 5. However, the question is saying, what does the arc length measure when that's a half of a radian? So if that's 5, and this is a half radian, that means that this is going to be 2.5 inches. So your answer for letter C, I can call this problem C, is 2.5 inches. Finally, in our last question, it's going to be similar to C, except we're going to use variables. I'm going to call this example D. It says, find the radian measure of a central angle that intercepts an arc of length S in a circle of radius R. So, I have my arc. The radius is R. The arc length is S. And I want to know x radians. This is what you will always, always, always do. Radians is going to be equal to the arc length divided by the radius. And now if I have 1 radian, we know that this number and this number will be the same. And when you divide, pretend this is like a 4. 4 divided by 4 is 1. But once the arc length starts to get larger, so now pretend this is an 8 and this is a 4. 8 divided by 4 is 2. I've doubled my arc length, so it's actually 2 radians. Okay, here are a couple more important formulas. We're going to be talking about circular arc length now. So, if I had a circle, just like I have been, and I've just been showing you this little piece of the circle, if I wanted to find this measure, the measure of that arc length, what would I have to do? Well, if I know this degree measure is theta, and I know the radius is r, these are 2 formulas you can use in order to find the arc length. So this is how I find arc length. If theta is in radians, we use this formula. S, this is S, the arc length, is equal to the radius times theta. If theta is in degrees, which we know sometimes that happens, then our formula becomes S is equal to pi r theta, pi times r times theta, divided by 180 degrees. Let's try an example. So this example asks you to find the perimeter of a slice of pizza. So it says that the perimeter of a 60-degree slice of large pizza with a 7-inch radius is how much? So I draw my pizza. I know it has a 7-inch radius, and I know that theta, my degree, mind you, it's being measured in degrees, so we need to use that second formula. 60 degrees, 7 inches. So now I'm going to say my arc length, S, is going to be equal to pi times the radius, which is 7, times theta, which is 60, divided by 180. And that's equal to 7 pi over 3, which is approximately equal to 7.3 inches. But that's not my answer, because S just represents the arc length. So 7.3 inches is my arc length. 7 is the radius, which I know this is also a radius. So now my perimeter is going to be equal to 7 plus 7.3, or approximately 21.3 inches in length. Here's another example. This time we're going to be talking about a track. So, pretend you're on a track team and you're running a race. Just a semicircle. The inside lane the inside lane is lane 1. The outside lane is lane 2. From the center of the track, the distance to get to lane 1 is 33 meters. From the center of the track, the distance to get to, I'm just going to draw it from here, lane 2 is 34 meters. If the lanes are 1 meter wide, which you can see they would be 1 meter wide, the inside lane has a radius of 33, the inside of lane 2 has a radius of 34, you should find how much longer lane 2 is than lane 1. So we're measuring the inside radius here. So we need to find what lane 2 is. The length of lane 2 is going to be equal to pi times radius, which is 34, times the degree measure, which we're measuring 180 degrees, divided by 180 degrees. You can see that those are going to cancel out. I'm going to get 34 pi. Lane 1, the inside lane, is going to be pi times the radius, which is 33, times 180, divided by 180. My 180s cancel again. I'm left with 33 pi. So how much longer is lane 2 than lane 1? I'm going to do lane 2, take away lane 1, and that's going to give me my difference. So 34 pi minus 33 pi is equal to pi. And pi is approximately 3.14 meters. So that means that lane 2 is about 3.14 meters longer than lane 1. In the next example, we've done one like this in the past, but now we're going to be looking at it a little bit more closely in terms of radians. So the question says, a truck has wheels 36 inches in diameter. If the wheels are rotating at 630 RPM, or revolutions per minute, find the truck's speed in miles per hour. So, what do we need to do first? Well, we know that the wheels are 36 inches in diameter. That means that they have an 18-inch radius. So I know R is going to be equal to 18 inches. They're rotating at 630 RPM, or revolutions per minute. I want to find the speed in miles per hour. So my ending units, after all my conversion factors, I want to end in miles per hour. Well, the first thing that we need to do is decide, what is this distance around the outside of the wheel? Well, the arc length can be determined by that. So if I'm trying to find the arc length of an entire wheel, that's 360 degrees. So I could do S is equal to pi times the radius, which is 18, times 360 degrees, because I want to measure the entire circle, divided by 180. I can simplify this because I know that 180 goes into 360 2 times. So my arc length is actually going to be 36 pi inches. 36 pi inches is my arc length. Okay, so now we need to find miles per hour. If I start with 630 revolutions per minute, I need to change minutes to hours first. So I'm going to multiply that by, I have to put minutes on top and hours on the bottom. And I know that there are 60 minutes in 1 hour. So now I have hours, miles per hour. So I'm good with my time, my distance measures. Now I need to figure out inches and feet. I need to change that. Well, right now I have that there's 360 revolutions. So, what's my distance or measure around one circle in one revolution? I'm going to have inches to revolution. One revolution we just found is 36 pi inches. Now I can change inches to feet. I know there are 12 inches in 1 foot. And then I can change feet to miles, because I know that there are 5,280 feet in 1 mile. And if I went through and crossed out my units, I'm going to change colors for this. Minutes, minutes, revolutions, revolutions, inches, inches, feet, feet. I'm left with miles per hour. So now I can multiply across the top, divide by multiplying across the bottom. I end up getting something like 1360,800 pi divided by 63,360. And that's about 21.477 pi, which is approximately 67.47 miles per hour. And that's how you would solve a problem that way. The last type of problem we're going to see is the length of a nautical mile, which you've probably talked about in some of your classes before. So, a nautical mile is actually the length of 1 minute of arc along Earth's equator. So, if I draw Earth, and just bear with me, my picture of Earth here, that's the equator of Earth. It's a sphere. If I called the center of Earth point O, and I drew a radius out to my Earth, and called that A, and this B. 1 nautical mile is the distance between A and B. It's actually 1 minute. We call it 1 minute. If we know that the radius of Earth is 3,956 statute miles, or land miles. I'm going to call them stat miles for short. I'm trying to figure out how many nautical miles it is for a certain distance. And in this problem, we're traveling from Boston to San Francisco. And you know that the distance is 2,698 land miles. I want to figure out what is that in nautical miles. And you might already know how to do this. First, we have to convert 1 minute to radians. I'm going to switch slides here. So 1 minute is actually equal to 1 over 60 degrees, right? We learned that in the very beginning. And if I want to convert that to radians, I need to multiply by pi radians over 180 degrees. And that's equal to pi over 10,800 radians. Now I want to find the arc length, so I have to use my formula S. I'm in radians, so I can just use r theta. I know that my radius, we just learned from the last slide, is 3,956. I'm multiplying that by pi over 10,800. And I get approximately 1.15. That means that 1 nautical mile is equal to 1.15 land miles. Conversely, if I went backwards, I could say that 1 land mile is equal to 0.87 nautical miles. So now let's go back to the problem. I want to travel from Boston to San Francisco. And I told you that in land miles, that's 2,698 land miles. I want to convert that to nautical miles. So I'm going to multiply by 0.87. And I'm going to get 2,347 nautical miles. In the next section, we're going to be using these to evaluate trig functions. So you really need to understand the difference between radians and degrees, because we're going to have to be in one specific mode to use the calculator to evaluate trig functions.